Let us first see what the differences between SQL and NoSQL databases are. SQL databases like MySQL, SQL Server, Oracle, PostgreSQL, or SQLite exist for many years. They are also called relational databases. NoSQL databases are relatively new. There are different subtypes of them, but in this video we will talk about the most popular type, the document-oriented databases like MongoDB, CouchDB, or DynamoDB. The big difference between them is how they store the data. Relational databases store their data in tables. Every row stores one piece of data. The columns are the same for each dataset. All tables and attributes build the schema of the database, which is relatively fixed, so all entries have the same data types. Document-based databases have collections that are similar to SQL tables. They store all pieces of data as documents. The documents can have different attributes, so there is no fixed schema. NoSQL documents are often represented as JSON objects, like this. They can contain nested documents or arrays, and the nesting can be as deep as you like. In document-oriented databases, there are two ways to store relations between entries. Documents can be stored as a nested property of another document. Alternatively, they can be referenced by their ID. Referencing is more flexible because nesting documents is only possible for hierarchic relations. But nesting documents can be a lot faster as the database does not have to create a new record and only has to add a property. So what are the advantages of each technology? The flexible schema of MongoDB makes it easier and faster to change the data model, but on the other hand, this increases the risk of having inconsistent data. Through the schema of relational databases, the data in them is more consistent. This has a cost, as the database has to perform more checks and verifications, and therefore NoSQL databases are faster for some operations. Relational SQL databases are better suited when your application needs more complex transactions. Another advantage of some NoSQL databases is that they are designed to be very scalable across different servers or even data centers. Now we want to test if the performance of a NoSQL database is really better for our use cases. For our test, we set up a simplified version of our social network. There are only accounts, posts, and likes. Accounts only have a username and a date of birth. Posts have a text content and can be liked by users. Concerning the database, this is a typical web application where there are a lot of read and write operations but few updates and deletions. For our benchmarks, we used MongoDB and PostgreSQL. We set up the databases in Docker containers to have a more controlled environment for the tests. For implementing the benchmarks, we used Python. In PostgreSQL, we have three tables: the accounts, the posts, and the likes. We did not build any indices except for primary keys, which are the IDs. The data in our MongoDB database is stored in two collections, one for the accounts and one for the posts. The information which account likes which post is stored by references in the post. This is a one-way reference, so in the account it is not stored which posts he likes. There are no indices except for the ID fields. We then executed several benchmarks matching our use cases, and this is the result. Inserting data, for example creating new posts, is faster with MongoDB than with PostgreSQL. MongoDB has to check less constraints because it does not have to ensure a consistent schema. Accessing data is faster in PostgreSQL, especially when searching for an attribute that is not indexed. We then tested to receive the latest posts. For this, the databases have to sort the posts by their creation date. We had 10,000 posts in the database and queried first 100, then 1,000 and then 10,000 posts. MongoDB was much slower than PostgreSQL in this case, probably because accessing values within documents in MongoDB is slower than in a table, so we can conclude that PostgreSQL is faster for sorting and scales very good. But when requesting the latest posts together with the count of how many likes they have, the result is completely different. This time, MongoDB outperformed PostgreSQL. The difference is that MongoDB only needs to count the number of likes in the documents, but PostgreSQL has to join the like post table and perform a count on that. This is exactly the advantage of MongoDB. You can avoid joins with nested documents. This benchmark inserts likes for a post. As you can see, MongoDB outperforms PostgreSQL once again. It just has to find a post using an index and insert an element into the array of likes. PostgreSQL probably needs more time because it has to check the foreign key constraints. Here you can see an overview of all our results. Inserting data is faster with MongoDB. Accessing data by an attribute is faster with PostgreSQL. Sorting is faster with PostgreSQL. Getting data with relations can be faster with MongoDB if the reference is stored inside the document. But when the reference is stored in other documents and MongoDB has to iterate over them, PostgreSQL is faster by simply joining the relation table. PostgreSQL is also faster for some more complex queries. Aggregations are faster in MongoDB. Our conclusion is that PostgreSQL is better at accessing data by non-key attributes, sorting, and for complex queries. And MongoDB is faster at inserting, updating, and for queries that use nested references instead of joins. So finally, we decided to choose MongoDB for our social network because of the flexibility and the better performance for our most common use cases.